Imagine a place where space bends, time twists, and reality itself breaks down. A place so dense, so powerful, that even light, the fastest thing in the universe, can't escape. These are black holes. But you don't really know what they are. Because what you've seen in movies is just the surface. The truth is far stranger. Today, we're diving into 15 terrifying, mind-blowing facts about black holes, facts so bizarre, they'll make you question the fabric of the universe itself. This isn't sci-fi. This is science, at the edge of what we know. Fact 1, black holes don't suck. They pull, just like anything else with mass. 1 to 2 o'clock. You've heard the myth. Black holes are like giant cosmic vacuum cleaners, sucking in everything in their path. Wrong. A black hole's gravitational pull is only powerful if you get very, very close. In fact, if the Sun were replaced by a black hole of equal mass, Earth would keep orbiting exactly the same way. No change. No spiraling. No destruction. That's because gravity is a function of mass and distance, not danger. What makes black holes deadly is how compact they are. You can get dangerously close before you even realize it. The point of no return, the event horizon, is where escape velocity exceeds the speed of light. Cross that line, and not even information can get out. But outside that boundary, it behaves like any other mass. Deadly, yes, but predictable. Fact 2, time slows down near a black hole, and may stop completely. 2 to 3 o'clock. Near a black hole, time doesn't work the way we experience it here. According to Einstein's general relativity, the closer you are to a massive object, the slower time moves for you, relative to someone farther away. So, if your friend stayed near a black hole for a few hours, then returned to Earth, decades might have passed here. This isn't theory. This is observed. GPS satellites have to account for time dilation due to Earth's gravity, and it's nothing compared to a black hole. Get close enough, and time slows to a crawl. Get to the event horizon, and for an outside observer, you freeze in time completely. You'll appear frozen forever at the edge, fading slowly into blackness. From your perspective, you fall normally, unaware that to everyone else, time has betrayed you. Fact 3, inside a black hole, space and time switch roles. 3 to 4 o'clock. Here's where things get weird. Really weird. Inside the event horizon, the equations of general relativity flip the script. Time becomes space. Space becomes time. That means, just like you can't stop moving forward in time outside the black hole, inside it, you can't stop moving forward in space, toward the center. No matter what you do, how much you resist, how powerful your engines are, you are pulled inward. Not just by gravity, but by the structure of spacetime itself. Reaching the singularity is as inevitable as reaching tomorrow. It's not just a death sentence, it's a one-way trip through time, but in the wrong direction. And what lies at that center? A singularity. A place where physics breaks, where density is infinite, and time, as we know it, dies. Fact 4, you could orbit a black hole, and survive. 4 to 5 o'clock. Here's the twist, black holes aren't just death traps. They're also cosmic dance partners. Many stars, yes, full-size stars, orbit black holes. Some of them do it safely for millions of years. In fact, we've watched it happen. The star S2 orbits the supermassive black hole at the center of our galaxy, Sagittarius A star. It completes an orbit every 16 years, flying at over 3% the speed of light. That's over 5,000 miles per second. The key is distance. Stay far enough from the event horizon, and gravity acts just like any other massive body. Close in, and the rules change. Too close, and you won't orbit. You'll fall, forever. But if you balance perfectly on the edge, you might orbit for eternity. Until something, or someone, nudges you. Fact 5, black holes can spin, and they twist spacetime itself. 5 to 6 o'clock. Some black holes aren't just sitting there. They're spinning. And when they spin, they don't just swirl matter, they swirl spacetime itself. This effect is called frame dragging. It means that anything near the rotating black hole gets caught in a whirlpool of time and space. Try to stay still. You can't. Space is literally moving beneath you. In fact, Around a fast-spinning black hole, there's a region called the ergosphere, where space is dragged so violently that nothing can remain stationary. Scientists believe some of the most powerful energy jets in the universe are fueled by this spin, matter twisted and ejected at nearly the speed of light. These black holes aren't just monsters. They're engines, powered by the most extreme physics known to science. Fact 6, falling in. You'll be stretched into a spaghetti noodle. 6 to 7 o'clock. Imagine this, you fall into a small black hole, feet first. Gravity at your feet is much stronger than at your head. The difference? Millions of times. This tidal force stretches your body into a long, thin strand. Scientists actually call this spaghettification. You're not crushed, not at first. You're elongated, atom by atom, into a vertical string. If you were watching someone else fall in, you'd see them freeze at the event horizon, and then slowly fade into nothing. But from their point of view, it's a quick, violent trip into the void. The scary part? There's no surface. No impact. You fall forever, until physics itself says, no more. Fact 7, black holes can be the size of cities, or entire galaxies. 7 to 8 o'clock. Not all black holes are created equal. Some are just a few miles across, with the mass of several suns packed into a city-sized space. Others. They're cosmic titans. Like TON 618, a black hole 66 billion times more massive than the Sun. Its event horizon is larger than our entire solar system. Think about that. A region of space so massive, so dense, that light from it left 11 billion years ago, and it's still warping the cosmos today. Supermassive black holes like this sit at the centers of galaxies, holding billions of stars in orbit, like cosmic anchors. Without them, galaxies might never have formed. These monsters don't just destroy. They may have made everything possible. Fact 8, black holes can collide, and shake the fabric of the universe. 8 to 9 o'clock. In 2015, scientists at LIGO heard something strange. Not a sound, exactly, but a ripple. Two black holes had collided, 1.3 billion light-years away. And that merger sent a wave of distortion across the universe. A gravitational wave. It passed through Earth, stretching and squeezing spacetime itself by a fraction of an atom. We built instruments so precise, they could detect a distortion 1/1000th the width of a proton. That one collision released more energy in a second than all the stars in the observable universe, combined. Black holes don't just break the rules. They send shock waves across reality. Fact 9, some black holes shoot jets of matter, at near light speed. 9 to 10 o'clock. Black holes don't just consume. Some of them explode. Not in the way you think. As matter spirals into a black hole, it forms an accretion disk, heating up to millions of degrees. Magnetic fields twist and snap, launching twin jets of plasma into space at relativistic speeds, close to the speed of light. These jets can extend for hundreds of thousands of light years. Imagine it, a beam of radiation from a single black hole, blasting energy across an entire galaxy. Scientists believe these jets might regulate galaxy formation itself, shaping the stars, heating interstellar gas, and triggering cosmic evolution. It's like the black hole is whispering, I create, and I destroy. Fact 10, there might be a black hole, in our own solar system. 10 to 11 o'clock. Something strange is tugging at the edge of our solar system. A handful of distant objects, far beyond Pluto, are moving in bizarre orbits. Too strange to explain with just gravity from known planets. Some scientists think it's a hidden ninth planet. Others believe it could be a primordial black hole, the size of a grapefruit, but with the mass of a mountain. Invisible. Cold. Orbiting silently in the dark. If it's real, it could be the first evidence of black holes created right after the Big Bang. And it could be closer than we ever imagined. Watching. Waiting. Fact 12, there could be black holes smaller than atoms. 12 to 1300 hours. We usually imagine black holes as giants. But in the first split seconds of the Big Bang, the universe was dense enough to form primordial black holes, microscopic, ancient anomalies. Some theories say they could be as small as a proton, yet heavier than a mountain. These aren't just hypothetical curiosities. Some scientists believe they might explain dark matter, the invisible stuff that makes up 85% of the universe. Billions of these mini black holes could be floating through space right now, including our galaxy, maybe even this solar system. You wouldn't see them. You wouldn't feel them. But if one passed through you, you'd be torn apart before you ever noticed. Fact 11. Black holes can slowly evaporate, over trillions of years. 11 to 12 o'clock. In the 1970s, Stephen Hawking proposed something radical. Black holes aren't eternal. According to quantum mechanics, particles constantly pop in and out of existence in empty space, including right near the event horizon. Sometimes, one of these particles falls in. The other escapes. This creates Hawking radiation, a slow leak of energy. Over unimaginable timescales, trillions of years, a black hole can lose mass, and eventually evaporate. The largest black holes will outlive stars, galaxies, maybe even atoms. But one day, in the far future, they will vanish. Not with a bang, but a whisper. Fact 13. Black holes might delete, or store, information forever. 13 to 1400 hours. What happens to information that falls into a black hole? Say you throw a book into one. Do the words, the ink, the meaning, just vanish? Quantum physics says information can't be destroyed. But general relativity says black holes trap everything, permanently. That contradiction created a decades-long debate called the black hole information paradox. Hawking once believed information was gone forever. Later, he changed his mind. Some theories now say information is encoded in the event horizon, like a cosmic hard drive. Others claim it slowly leaked out through Hawking radiation. No one knows for sure. But the answer might reshape quantum mechanics, gravity, and reality itself. Fact 14. Inside the singularity, physics breaks. 14 to 1445. At the very center of a black hole lies the singularity, a point of infinite density. That word, infinite, is where science fails. Every equation breaks down. Every constant goes wild. Time, space, matter, energy, they lose meaning. What exists there? A tear in the fabric of spacetime. A door to another universe. A glitch in the simulation. We don't know. And we can't know. Because no signal escapes from the singularity. It is the most hidden place in the universe. The end, and possibly the beginning. Fact 15. Black holes might be portals to other places or times. 1445 to 1530. What if a black hole isn't just an end, but a tunnel? Theoretical physics allows for wormholes, bridges through space and time. Some solutions to Einstein's equations describe black holes that connect 2 points in space, or even 2 universes. These would be called Einstein-Rosen bridges. Science fiction loves this idea. But they're unstable, dangerous, and hypothetical. Any attempt to travel through might destroy the tunnel instantly. And yet, the math holds. If we could harness exotic matter, negative energy, and impossible engineering, maybe one day, black holes could become gateways. Not to death, but to elsewhere. Final message, 1530 to 1600 hours. Black holes are not just terrifying. They're fundamental. They challenge our understanding of time, space, information, and reality itself. Every time we look closer, we find deeper mysteries. So if you thought black holes were just cosmic monsters, think again. They might be the key to everything. Subscribe for more stories from the edge of the universe.